Also I'm Leo, and I'm Austrian, and I came from the center from electron microscopy to EMBL. My first day was in 1978 between Xmas and Sylvester, and my contract starts at 1979. I'm a precision mechanic, no? And I came from electron microscopy in Graz. We was in the world very high standard, and EMBL was at the beginning with electron microscopes. Arthur Jones was our boss. Yeah, he was our boss. No? And the curious thing was, in Graz, 50% was the financial was from Graz, and 50 we have to make it private to sell things from us. And so we was not only science, but also production. And in EMBL, I found pieces what I made in Graz. EMBL bought it from us, and I found it here. Oh, okay. That's a curious thing. No?
So you are widely regarded as the genius of the workshop, who for decades contributed to building imaginative new pieces of equipment, to solving technical problems. What type of things was the workshop doing when you first arrived, or what did you see your mission?
If I came here at first, my eyes goes big. I saw these big hall with big machines. We never had so big machines in Graz. No? At first I said, wow, what's that? No? But great. No? And the first project was we made for Hamburg, for electron synchrotron in Hamburg for DAISY, all the instrumentation equipment. We made vacuum tubes 22 meters long from stainless steel, welded, and detectors and so on. No? And I went to Switzerland to make a welding course, 3 weeks, to make high vacuum welding for Hamburg. And this system still exists there. These tubes with this diameter, no? And this was the first project what I was in contact with EMBL. No? And also we made them for the fixing the beam, so big mirrors, a lot of them. It was like a bench, but it was so big, and with maybe 50, I cannot remember, maybe 50 mirrors with gold plated. No? We made everything here. No?
So you ended up having to find solution to translate what was in the mind of the scientist and on paper project and actually build it physically from scratch.
An interesting story was with Jacques Dubochet, this cold finger, no? And I was included in this cold finger, no? And he got later the Nobel Prize. No? And Lucian Vollhardt, no? But I'm not the only one from the mechanical workshop. I will tell you, we was a lot of people, you know.
Yes.
No? More than 12. No?
So what was the thing that you built for Jacques' methods? And also you mentioned Yanni, so I think there they were doing a large screen, so there was probably a lot of equipment to help them out screening. So I was curious, what did you build for them?
Yeah, we made this one, and we at the first the prototype, and then we continued to make it in an industrial standard, no? And then the industry got it, no? And the prototype is here in EMBL. You see, there is a newspaper with Jacques Dubochet, and he holds this cold finger, no? And this prototype is by Yannick Schwab. You can see it, no? Okay. But this was not the only project. We made a lot, no? We made so. We had some equipment which we bought it from other firms, but it doesn't work properly, and so we changed it. No? So gel dryers and a lot, because the instrumentation in this time was very, very big, and was 50% was instrumentation, no? And the other one was microbiology, no? And then it changes a little bit. No? And
yes, yeah. I remember the equipment you made was really high quality, and when I finished working at EMBL and moved back to Scotland, I bought I bought some of your equipment and took it back with me to start my lab because it was reliable and high quality. What projects do you particularly remember as exciting ones to work on?
Project, we was a lot of people, and every people makes pieces of them. No? One I can remember, and it was very interesting. I was working, I think he was Japanese, Kim Lok-song was his name. And I was working 3 years for him, and we made a centrifuge for blood, and then you can take, normally you have centrifuge, it turns, and then you take out the tubes and separate it. But this machine, it runs, you can fill it inside, and it was not necessary to stop the machine. This was a very, very interesting, And the interesting thing, and also complicated, was this rotor was from aluminium, from 2 pieces in this diameter, and then there was no sealing between, and there was a special foam inside, and so it rotates. Then it separates the blood, and the whole unit, it was maybe 10 kilos heavy, and this was a steel tube from 3 millimeter diameter, and the thickness was 0.2 millimeter, and it hangs free at 10 kilo on this one, and it rotates more than 10,000 RPMs per minute. This was a very, very interesting project, and I remember remember on Kim Lok Song, we start in the morning with tea from rose plate, and then we start. And the experiments, sometimes it was here until 3 o'clock in the night. But it was so interesting. For me, it's a paradise.
Yeah.
And I'm a technician, and EMBL was always a paradise for me. It was not only a job. It was for me like hobby.
I think I'd be very interested to hear how, over the decades that you worked here, how technology changed and how that maybe affected the types of equipment that you could build. Did you see that happen?
Yes. The technology changes because the machines, milling machine, lathe, and so got more modern at the beginning. We had one of the first milling machine with NC steering. One of the first, a very, very small, it's called Maho, and it can only go 1, 2, 1, 2, and 126 sentences you can program, not more. And this one of the first all over the world. Made from Junghans was the firm. They made the electronics and Maho the body. But then later, this technician from the machines goes more and more, and then we had the possibility to make things more complicated and more precise. We had milling machines, they were so high, the milling machine comes until to the roof. The movement was more than 1 meter. The table has 1 ton. And with this machine, we made this big equipment, these vacuum tubes and so for Hamburg, otherwise no chance to make it.
How do you see the future developing? I mean, one thing that I've been very excited about in seeing the opportunity with 3D printing and seeing the technology emerging to make things. We've already made some very simple things for
printing. We have printing machines, and the very, very good thing on printing machines is you can produce pieces in one piece. It is not possible to make it in one piece with a milling machine. But if you need very precise things, so you need to nevertheless need milling machines. We have a 5-axle machine, a very, very high quality 5-axle machine, and the preciseness is 2 μ. And this, at the moment, is not possible with printing for this precising. But we start also with printing for some years in EMBL, and now we have very good printing machines, and we try to make every piece what is possible to make it printing. It's good because printing, you don't cut away things, and so it's also cheaper.
Yes. And which materials do you think in the future the printers will be able to work with?
I know also on exhibitions. I know on medical exhibitions, they print from stainless steel, implantate and so. And for this is good because the surface is not shiny, it's rough, and this is important. So the bone can go inside, and they print. Or we can print stainless steel. We can print plastics. So in principle, you can print everything. But only you cannot reach the preciseness if you make it with a milling machine or with a lathe or so. Sure. But maybe in the future, maybe the printing technique goes more and more and more. In one time, maybe it will be standard, so you can print it, and it's not necessary to work it afterwards. No? But nevertheless, you can print pieces, and you make only the finish. So it's easier, no? And yeah.
One thing that I was thinking, I mean, with all this creativity in building new things, I was wondering, there must have been a lot of transfer from the things that you were developing, the object that you were developing in the lab, and then industries or companies that eventually would sell. This certainly happened with, microscopes, right? With all the partnerships. So I was wondering, what was your, if you had stories related to that, or particular things that remained in your mind of transferring into something that became, largely used or made the fortunes of a company.
Yeah, we made something I can remember. I made it with Christian Bollin, and we made, how can I say, a push bed. It should be as a training for doctors if your heart is still and you push on it. No? And so we made a push bed where they can train it. This is one small project, and then he is sold. It goes into the industry. This is one project, and I think a lot. This is also a point from EMBL to find solution, and if it works, so give it to the industry. No?
I mean, I always, one of the first memories of the mechanical workshop was also the chambers for running jazz made in plexiglass. These things are sort of classics, right?
Sure. For the lab equipment and the running shells, no? When you can buy it on the industry, no? But the quality from us is completely different. But now it's exactly the question, what's the reason that the quality from the industry is not so good? It should destroy after 2 months or so, and you buy a new one. But our solution is make the best quality and should work for years, because we make it not to make business. I want to make a solution, the best service for you what I can. And so I use different material, very high quality material, and have some electrophoresis chambers. I made it in 1989, and it still works. But this is not the idea from the industry. I understand they have to make business. No? But in science, for us, it makes no sense if electrophoresis chambers, they cost 1,800 euros from Biorad, and 1 month later the scientist comes to me, please Leo, repair it, it's broken. This is, I think, too much. We made electrophoresis chambers exactly what you need. From the industry, it's only standard. Use it or don't use it. But you came to me and said, Leo, I need electrophoresis chamber, for example. I need these slots and so and this size, and we make it. This is prototypes, and this is also the main function from the mechanical workshop. You want to have special solutions, you make it.
Something I would like to hear your view about. In our work, we see the field changing because computers become such a big part of our day-to-day work. When I started, I used it for some things, but it wasn't the major part of my work. Now computers dominate everything. Data scales up. Do you see this also in
the mechanical workshop? It's the same. Because the machines, our production machines, you can only use it by computers. Otherwise, no chance. No? Because you have a very complicated geometrical form. No? You can make a band, but you need 2 weeks or so. No? And so we make the program, and 30 minutes later it's made. No? So without no chance, because these machines don't have a handle, you have only a chance to work with it with computers. And so I send my guys to training every year, maybe for a month. It's so complicated.
For computer-assisted design.
And to make the program to use this machine. The machine, we have the smallest what we got, because otherwise I had no chance to put it through the door, 400,000 euros with equipment. Okay, for a microscope it's nothing, I know. But nevertheless, for the workshop, yes. No? But to use it, it's very, very complicated. And every year they continue the software, and so I send my guys to training, otherwise no chance to use it properly.
I mean, another thing that I was curious, coming back to life in the lab, on this business of adapting to the scientist's needs, was, for instance, you know, in my own line of research, we use the insect and Drosophila that needs these incubators and things. So you must have worked also on, you know, a lot of trivial machines like, you know, thermostated chambers or incubators or this kind of stuff.
This is a project,
right?
and I a little bit proud about that. Mm-hmm. We start 1999 with this incubator system. Without these incubator systems, no chance to make long-time imaging. No? And we are the only on the world with a special system. All the Zeiss and Nikon and so, they also sell incubators, but they are not tight and they are not so precise like ours. Our incubator is completely closed. The climatic inside is completely closed and very, very preciseness from the temperature, humidity, O2 reduction, CO2 and so on. No? And our system is the only one. No? I don't want to say the industry has not the possibility to make things like that, but the business is it. And I had a talk with a Leica guy, and he said they was very interested at the beginning to take also this business, but he said he have to make an incubator box 400 per year. Every incubator box must be completely the same, and so that's it. But the incubator box we made, since the whole year of production incubator boxes, maybe 400 systems, and really no system was the same. Every incubator box is a prototype because the microscopes are different, the setup are different, and so you have to change the box, measurement different, everything is different, no? And so for the industry it's not interesting. And this is the very, very good point for us, and we are still in this job, in this business. No? And the next thing is also, I like this project because a lot of scientists in EMBL, they left EMBL and then they want to have an incubator box. We make it, and I travel to them. I meet the old guys, and I love it, and see other institutes, what they have.
But it's a very interesting concept of providing the best quality and building systems on demand for slightly different needs, which is something that the industry cannot really be done, or it becomes very expensive to do it. And I mean, it is also great that this requires very intimate knowledge of what the scientists are doing. So the other thing that the industry cannot do is really matching this knowledge, because, you know, they deal with production mostly and not really with really developing and prototyping.
You're clearly a great example of someone who's fascinated by how things work, wanting to know basic things. I think we were talking earlier, the society today is changing, so less people ask how do things work. We are surrounded by equipment and electronics and machines, and we just accept that they are there, and we don't think how to repair them or how they work. How can we excite the new generation of young people to take an interest in how things work?
I think a little big problem with the new generation is, how can I bring the new generation that they are interested to know how it works? They only take this one and they say it is so. Yeah. For me, it was never. I want to know what's the reason that it works. And if you don't have a look what's the reason, you will never find new solutions. Absolutely impossible, is my meaning. No? And now is my question, how can I make with the new generation that they think the same as mine and say, oh yes, I want to know how it works. No? And then you will be a successful technician or so. No? But only with the school what you learn, this is only a start, not more. It's like a driver's license. No? He shows only how the car works, but learn you must by yourself.
So, Leo, you worked at EMBL for over 4 decades. You see science change, the workshop change.
Change the director generals.
Director generals change, group leaders came and went, PhD students came and went. You saw it all. If I could ask you now, we're celebrating 50 years of the EMBL. If we look ahead 10, 20 years, how do you see laboratories changing, EMBL, the role of the workshop? What will the laboratory of the future look like? Will it be robots? Will it be automation? What will What will be your opinion about the future of laboratory science?
With machines and so robotics will become more and more, because if you have to replicate pieces or so, you make one piece. Also our 5-axle milling machine, you make one piece, and if you need more, I put only the material inside, put it on the button, and it is 100% the same. If I make a mechanical, human, you make foils a little bit and so on, but for the production and so on in the mechanical workshop, in the future it will be more with robotics and so.
Yeah, I mean, I guess there is such an advancement also in the computational part that then you have to translate many of these things probably in the physical world. Yeah. So you will need, I guess, some scale up also of the machines that are translating that into some work. Right?
But not only the machines are important, also to get precision mechanics, because in the meantime, the precision mechanics is a very, very complicated job. And to find good guys is absolutely complicated. If I was there and I was looking for new guys, I was always looking maybe over a year to find one guy. And then he came from the center workshop in Neuenheimer Feld, or Max Planck Institute, as a people from institutes, otherwise from firms, no chance. I don't want to say they are not good, but they are only in one line and they are trained only for production for this firm. But in EMBL, in the mechanical workshop, you must be very universal, because you have to know from physics, you have to know from chemicals. It's very important if on incubators and everything, or we made also for the laser microscopes, for cells. We had at the beginning, to Stelzer's time, very problems. The cells dies. We used for the body stainless steel and also steel for chirurgical steel, but it didn't work. They died. And then I asked him, what is the liquid which is inside? And then I had a look, and then I saw, oh moment, steel in this one will not work. Yeah. It gets like a battery, intercrystalline corrosion, and it is a battery, and this power, this small one, destroyed the cells. Mm-hmm. That was the reason. And so, for a precision engineer, it's very important to know the materials, the function, and how it works with liquids. And so, otherwise, you cannot make it. That's the reason we work with PEEK. You know PEEK? The special material, the laser microscopes, only PEEK. A very, very high efficient and expensive plastic, but two things: it's completely not poison, and if I cut it and so, it's also very stable from the measurement. Because it is not stable, you cannot use it. If you have temperature differences in the microscope, you cannot make an image. And so there are a lot of points which you have to know about the materials, since laser microscope, or doesn't matter, no? Or we made a lot also for aquariums and so, or for deer house. You have to know not only steel is steel, no, you have exactly to know which material I have to use, otherwise the animals will die or it will not work.